Okay, so let me bring the slides. So this is a slide from the lecture number 6. If you haven't looked at it, it's good for you to actually look at it. Okay, so essentially we talk about the concept called distributed object. So distributed object is, by the way, the picture that you have, the person.cpp and transaction.cpp, what you're working with for homework assignment number 2, is essentially being brought into the context of distributed object as well. So now we have, because back then we don't know inheritance, now we know inheritance, that we actually put what we call a parent class called core object that's actually cover both person and transaction object. Okay, so this is now we have a transaction. So over here, I just want to remind you, we not only talk about inheritance, we also talk about virtual function, which is another very important feature for object-oriented programming to support polymorphism. Really, that the virtual function is the C++ and a few other object-oriented language, their way to realize the concept of what we call polymorphism. So polymorphism means that when you call an object, that not necessarily this object always respond to the same method, exactly the same behavior or implementation, depending on whether this object originally is. For example, in this case, that we have a subclass called flight, which is a subclass from transaction. And flight, of course, is also a transaction, but it's a more specialized transaction. So we have this hierarchy, or what we call class hierarchy here. All right, so what we really want to do is to implement this picture. Sorry, I have to go back to my previous slide. Yeah, this is the picture. So remember, in homework assignment number 2, for example, you try to get the distance. You try to get the distance about a particular transaction. Okay, for example, you want to get the distance between New York and Davis. So that's what you have been calculating between Davis, New York, and Sydney, Australia. The thing is that maybe, okay, you're doing this transaction, but you realize when you want to obtain the location of a person, and that person might not be actually with you right now. That person might be belong to a customer really in New York. So you're running this program in a server at Davis, but the person who actually have that locality New York, that probably in a server in New York itself. So in some ways that you cannot just simply just gather the information together and then try to perform the computation. That has a lot of issues if you want to do that, because number one, you might not have that information, and number two, it might be illegal for you to even bring that information as an object to a particular location. So you have to think about, when I do computation, my objects are distributed around the globe. And how do you actually still be able to write the program in object-oriented fashion and then still be able to get to that? So in this program, I'm going to show you for homework assignment number 3, essentially you have a client that's actually in server number 1, machine number 1. And then you have another machine, which is actually running some of the real data. And yet, in the machine number 2 in the middle, I'm pointing out some of the objects it need to access may be actually in yet another server. So we actually have a 3 server from server number 1, which I will call the HW3 client, to, let me actually write down the name so it will be easier for you to know what I'm talking about. And the second one, I will call it HW3 server. And yet another where's my, wow. Anyway, it's actually somewhere down there, but I'm not going to bother to roll my stuff together. I call it HW3 another. Okay, I have a 3 program running on 3 different machines and maybe using 3 different port number, and they will cooperatively, sorry, to actually implement exactly the function that you have in homework assignment number 2. Okay, so you can see that I have a 3 program. For example, get distance. You think about get distance is actually getting the GPS location for 2 different GPS or 2 different persons object. And the thing is that you have a place which you want to perform the computation. You have another place that's actually locate person number 1. And then you have yet another place is locate person number 2. And so your information is essentially split into 3 different places. And how do you actually be able to write the object in the program to actually put them together to do the programming as if it's running on a single machine? Okay. By the way, any question at this moment? Okay, I'm going to show you a quick demo to see what we're talking about. Okay.
Excuse me, Professor. Earlier you mentioned polymorphism, and you were kind of talking about how it's when an object doesn't always respond the same way, and then you said depending on, and my notes cut off there because I missed the end of that sentence. So can you just explain that one more time?
Right. Okay, I will I was saying that when you call so the word polymorphism means that the same object might have, when you call a particular method, say get distance, and it might have a different behavior. That's polymorphism, means that it has a multiple way of responding to the same message. So that's called polymorphism's general definition. So in C++, this means that when you call a member function of an object, and sometimes the real code to respond to ask to be invoked is going to be different, depending on how this object was created. In fact, in C++, let me give you an example. It was a good question, but let's put it this way: in this inheritance hierarchy MIA, that transaction is a parent class for flight. Okay, transaction is a parent class for flight. You know what? I have a better slide to talk about this. Because I already put down all the object code, so you will know what I meant. Just give me 1 second. This is 6. This must be in 7. So good. Okay, I will use this. I think this is a good example to talk about. So you can see that I have a parent and a child class. The parent is a transaction, the child is flight. And the thing is that I define a method called conflict of interest, for example. A function that's actually exists for the parent class, which is transaction, and also exists for the flight. also exactly the same name. This is called virtual function. Virtual function means that you declare a member function and you declare adding the keyword virtual to say that this one is virtual. And what is a virtual is going to do for this case? So if you don't have the virtual, assuming you create an object that is a flight object, and later you casting it. Casting means convert that flight object into a transaction object. So the thing is that from the programming perspective, you see this pointer or this object reference as a transaction. It was created as a flight, but now you convert it to a transaction. So if you don't have this keyword virtual there, when you call conflict of interest, it's going to call the transaction, the parent class implementation of a conflict of interest. But if you don't do the casting, then it should call the fly class, the fly implementation of conflict of interest. That's assuming you don't have virtual function. Then basically, I want to see the type of the object I'm dealing with. Are you doing the casting or without doing the casting? By the way, I use casting for those of you who hasn't done C programming, that this is a very commonly used techniques for you to kind of convert from one data type to the other data type. We call the casting. For example, it's a very common we cast a pointer to an integer, or we cast a character star, which is a pointer to a character, to a pointer to void star. Okay, so that's what we call casting. So when you do casting in this language, you essentially change the data type of the data structure you try to access. Okay, all right. Are you with me so far? Are you okay, Mia? Is that clear? I haven't talked about virtual. I'm just talking about without virtual. That's what casting is doing.
So I think I'm just lost. I'll have to look at more of the lectures.
Okay, so there is a concept. Okay, let me show you this. Okay, let me try to.
Well, let me clarify where I'm confused. So you're saying that so Paul, this is an example of polymorphism because when you make a call to conflict of interest, it will react differently depending on whether it's shadow flight or flight.
Yeah, let me actually make it. Don't worry about shadow flight because shadow flight is actually further confusing stuff. So let me just between transaction and fly. Yeah, between transaction and fly. Don't worry about. Let me remove this. I know shadow fly.
Sorry, I thought the Boolean belonged to flight and shadow flight. I see now that it belongs to transaction. And
no, you're right. It is actually belong to fly and shadow fly. But I thought it might be easier to explain between transaction and fly. So that's why I'm actually changing the code here. Okay, so you can see that now I have this two. This is I modify Mia and other students, that I have a transaction class of a fly class, right? And now I'm actually have a member function called conflict of interest. But this member function conflict of interest is not virtual. Okay, now I'm not talking about virtual function at all. I'm talking about regular. So when you have a regular function looks like this, and it depends on how you cast the object, that you will decide which version of the function you're going to call. Okay, for example, I'm going to write the C code. So, for example, if I have assuming I have a flight star XYZ, which is a pointer to an object of a flight, right? And then I actually, when I call it, I call this way. I call transaction star XYZ to the conflict of interest. Okay, assuming I'm, let me just, don't worry about syntax. I know there's a lot of syntax error here, but I'm just want to get to the point. Let me go to a fun I think I can deal with here. Huh, this is really big. Let me make it smaller. Okay, now I think I can deal with this. Okay. Okay, I'm going to ask this question to everybody here. Okay, let me bring this back here. So assuming I'm not doing virtual function in the beginning, at the bottom of the screen, when I have a pointer, which is this pointer was actually a pointer to flight, but I cast this pointer with the parent class pointer format to that variable, to that pointer is pointed to the object, of course, is object. And then I call conflict of interest. My question to all of you is that which conflict of interest function is going to be called? Is the parent version or is a flight version?
Parent version,
Is
I'm
a
gonna guess.
transaction's conflict of interest or the flight's conflict of interest?
The parent one.
Anybody want to guess?
The parent one, transaction.
Yeah.
Jenna, you want to say something?
Yeah, I saw the video, the lecture 7, and I got
Wow, I got
this sense.
silence here. I mean, this is. Oh, wait a minute. Okay, of course, I always say write the program. You can find out yourself about this concept. But let's get to the point. Let me get to the point. In this case, if it's not a virtual function, it's always transaction, because the transaction is the type that's actually derived the compiler to actually bind the function conflict of interest to the conflict of interest function that's actually associated with the type. So the compiler is actually make that decision for you to actually call that. Okay, so this is called without virtual function. It's just purely what we call typecasting. And with typecasting, then you basically call whatever type is being cast into, and then you call that function. Okay. Is that okay with everybody?
And
any
so,
confusion? Because I want to make sure that everybody understand this part. Because if you don't understand this part, it's really hard for you to understand what virtual function is.
So
it's a compiler choice. Just to let you know that the G++ compiler is actually detecting what is the type of the object. And then they would try to find the function that's associated with that type, and then they will invoke that function. Because you change the type from flight to transaction, that's basically telling the compiler change to a different function for me to invoke. Okay, this is without virtual function. Is that okay, or I'm actually don't have a good feeling because you guys are pretty silent here, or I'm actually.
I think you made it more clear on the lecture 7 video about this one. Hello, you hear me?
Any question? I'm sorry, I didn't see the chat. If you say something in the chat, I couldn't see it.
Professor, can you hear us over the mic?
Oh, wait a minute. Oh, did I mute everybody? That's not good. How can I mute everybody? Let me see. How do I unmute everybody? Can you unmute yourself, or how do I do that?
Can you hear us, Professor?
It's not good.
What a funny thing to catch on recording too.
Can you hear me?
Yeah.
Okay,
How
I'm
about
sorry.
you?
No, I can hear all of you, but I don't know what I did. I'm not intended to.
Okay. Okay, because we were responding and you weren't hearing us, so you whatever it was, you fixed it now.
Okay, I'm sorry. Horrible.
That's okay. So I just wanted to check. So this example that you've come up with, like demonstrating typecasting. So typecasting, it converts the data type, and it's an example of how you can implement the concept of polymorphism. Is that
No,
was
no,
that?
this is not polymorphism yet. This is not polymorphism, just to clarify. This is just basically saying that object's behavior, a call, when you do a function call, a member function call, the behavior is associated with the type you're dealing with. So this is the compiler's decision about what function you're going to call. And I just want to contrast with polymorphism, means that even if it's the same type, you might have a different behavior. You might actually call different function, which I'm going to show you next. To compare, you can see what polymorphism is in the
Professor,
next slide. Yes.
Can I answer something? So what
Sure.
if we had just a pointer pointing to an object and you typecasted the pointer?
Yes, it's the same thing. It's the same thing.
Right?
Pointer and the reference and object, they're the same thing from the compiler perspective. Pointer is a type, right? It must be a type, a pointer to some type. So as long as you have a type, that compiler can figure out what is. Think about compiler. How you're going to write a compiler is that they're going to link your code. Whenever you call a function, they have to unambiguously find the function to call that function, right?
Mm-hmm.
So that's the job of compiler, and therefore that's nothing magic here. But until we look at virtual function or polymorphism, which is very different because the compiler lost that information, and in fact, compiler didn't make that decision. It pushed to runtime to make a decision. It's very interesting. Virtual function, you will not bind which function you're going to call until runtime. The compiler have no power there. So that's really different and really interesting. And that's why it's a polymorphism, because until you run the program, you don't know which function you're really going to call into.
Okay.
Yeah, that's the big surprise. I hope you get that. That is really important for you to understand what the virtual
Professor,
function is. Yeah, go ahead.
So when you define a function or a method as virtual, then the compiler waits until runtime to check what is the type of object the pointer is pointing to.
A little bit more complicated than that, but let me actually simply say this: is that the compiler, when they realize it's a virtual function, it will create a table. We call it a virtual table.
Okay.
And it basically just refers to an entry in the virtual table. But at the runtime, that virtual table will be filled up with what we call pointer to functions. So I know some of you probably never heard about this term called pointer to a function, because pointer to a data or to a memory, that's okay. But pointer to a function is essentially pointing to the memory address of the first byte of a memory. The function, where the function is in memory. So that's why it's a pointer to function. That's for some of us it's so exciting. For some of us it's so evil. That's totally forced the programmer to think about memory instead of just a programming language. Yeah. Okay, so that is for if you're a Python programmer or you took ecs36b equivalent in other language, then C or C++, that this is a part I think is really different, that you miss this part. So don't worry, I'll be happy to bridge the gap this way. But this is really the only difference, okay? All right. So this is a regular function. I'm going to move to the virtual function, how it looks like, okay? Is that good? Okay. So now I'm actually adding the keyword virtual. I'm adding the keyword virtual. When you're adding the keyword virtual, the code I showed you earlier, because this object was created as a flight, and therefore, even though you cast it, you're casting that object into something else, to transaction. But when you call it as a transaction, it will still invoke the member function of the data type that this object was originally created as which object. Okay, let me repeat it again. So instead, to make an answer short, if you have a virtual, I'm going to call the fly version of the function regardless. Regardless, you casting me to transaction or even casting me all the way to core. You can casting me through the whole inheritance hierarchy to the top. And yet when you call this function, it's still going to ask you the lowest level, whatever the data type that create the original data type that create this object. So that's the difference. So you can see that in this example, I just want to say, without virtual function, you're going to call whatever is casting into. But with virtual function, you protect that original class, and then you will invoke that one. Okay, so why this is powerful? Now I'm going to tell you that why we call it polymorphism. So for example, I have a transaction here. I have a transaction. The transaction, grocery shopping is a transaction. Fly is a transaction. Move money from one bank to the other is transaction. You have a grocery class, you have a fly subclass, you have a bank subclass. They all under transaction. But for me to process, I actually cast all the pointer into transaction start, into the transaction abstraction. And then I put all of them into one single array. So inside the array, you have an array of pointer, which is pointer of a transaction, but you actually don't know what's their original class. What's the original class? Was this a banking transaction? Was this a flight transaction? Was this a grocery shopping transaction? I have no idea at that point, because the type information has been, the keyword casting already removed that association. Okay, but don't worry, if you declare it's a virtual, then basically that particular association is being implemented using virtual table and also using pointer or function. And so at the runtime, because when you create this object, that it was created as a fly, so therefore that virtual table on your memory has been configured, associated specifically to this object that actually has a pointer to the right function to call. So therefore, you're not doing a direct call. If you do a direct call, that's a compiler's job. Compiler can just do a linking, you can just call it. But this is actually a runtime support. You almost do an indirect call. So essentially, you go to a place to grab a pointer to function, and then you call that pointer to function. That's what virtual function. So that's a whole issue about what virtual function is, number one. Number two, what is this had to do with the virtual table, which is a function pointer? That's number two, because it's shifting the decision about the function binding from the compiler time to runtime. And that is a huge difference that we need to understand as a C+ programmer, that what decision was made at compiler time, what decision was made at the runtime. And number three, that because virtual function has this behavior, in such that virtual function is more expensive than regular function because you have a one extra direction. So therefore, if you are performance sensitive, then you know you're going to pay a price because you're not going to direct the call. So which means that all the compiler optimization cannot touch this part of the code because it has been redirect to another pointer. Okay, so there's a lot of interesting implication about this part about the design for virtual function. Okay, and yet another one which you have to probably go through lecture 7 or lecture 8 when I talk about the difference between virtual inheritance and multiple inheritance. So I just want to tell you, you probably heard me saying multiple times. When I talk about inheritance, I always talk about single inheritance. I feel single inheritance is the only inheritance I feel the most easily usable inheritance concept. But a lot of people in inheritance, object-oriented programming, they jump into multiple inheritance, they jump into the more complicated inheritance scenario, which a person can inherit from multiple parents, and then this is so good that I mingle all the idea together. I mean, that's actually sometimes, if your application doesn't need that, don't touch that because it's really complicated, especially in C++. A lot of people in C++, by the way, they don't know the difference between virtual inheritance and multiple inheritance. They're both, let me actually show you the multiple inheritance, just one slide, because I do that in my lecture. But I can tell you that even the very senior people, programmer, they told me that they're surprised. They never know the difference there. So that's why I want to warn you. What did I do? Oh, here. So let me show you the code. The code looks like, let me just, okay. I know what I'll show you. You can see that this is an inheritance. There's a single inheritance, multiple inheritance, and virtual inheritance. I actually explained in lecture number 8. So the code looks like this: the class account, class employee, class student, class work study. The hierarchy looks like this, right? Account is the top. And then you have somebody who is an employee of UC Davis, and you also are a student taking ecs36b, and therefore we define another class called work study. So that's why work study multiple inheritance or virtual inheritance from both employee and student. Okay, but if you add the keyword virtual and without adding if you add the keyword virtual here, this is called virtual inheritance. If you don't have the virtual keyword, it's a multiple inheritance. Okay, and what's the difference? I mean, you're thinking it looks like this, but if you really look at the memory layout, let me actually show you. It's actually this two. If you do multiple inheritance, it actually looks like this. And multiple inheritance is not virtual, so you actually have a 2 account object. Even though you thought you're having this picture, account shared by employee and student and work study, but if you do multiple inheritance, you're actually having things like this. But you do virtual inheritance, you actually do things like this. So that's the difference from the difference between virtual inheritance and multiple inheritance, adding that virtual. And the other thing is you look at your memory layout. If you look at your memory layout, you will see account E, employee, account S, student, work study. But if you do virtual inheritance, you actually see this 2 part. This 2 extra part is called virtual table pointer, because it's just like a virtual function. It's a pointer pointing to that virtual table, so they will be able to implement this concept. Okay, it could be really tricky, but hopefully this part, this lecture, when I talk about virtual and multiple inheritance, will actually give you some perspective about how language, when they interact with the memory layout, it actually could be really complicated. And a lot of very challenging bugs that will occur because you don't see the difference there. You might override to certain bytes. That's actually your virtual table pointer. And because you've done that, I'm sorry, if you use B0, this kind of thing, you can easily wipe out this vtable and vtable pointer, and your program will not run correctly. That's why I'm always thinking that unless you're necessary, I really think that this is based on my personal experience. Where do I have that? If you can take care of take care of your problem with single inheritance, do it. Okay, 99.9% of the question I have dealing with single inheritance is good enough, and multiple and the virtual inheritance is usually just give you a lot of headache without really help you to solve too much problem over single inheritance. Okay. All right. Any question? All right. So you know what? I cannot get the chance to really show you the demo for homework assignment number 3. Are you still there? Hello? Did I mute everybody again?
I'm still here.
Okay. All right. Good.
Yeah, we're here.
Yeah. So I'm just, you know, I mean, I'm really glad that this is much better for my pre-recorded lecture, because in the pre-recorded lecture, I just don't know which part that I should have explained differently to let you. I don't know your question, which part which make you confused. But with all of you here in the Zoom session, I feel a lot better, and because I kind of know where is the key point I should try to explain differently and help you to understand this pretty challenging topic here. Okay. All right. I'm going to postpone the homework 3 demo until Monday, because you can see that it's pretty the concept is already pretty interesting, but you will see the real code, and I would just run the code once, okay, to let you know what happened. So I just make a clean, and then make, and then I will move to the smaller office hour for today. So I actually have a 3 program. You can see that I have HW3 server, HW3 client, and HW3 another. Okay, so I'm going to first run HW3 server. I mean, between server and client, that's okay. And then I'm going to run HW3 client. In fact, I'm still running HW3 another. Okay, and then I'm going to run HW3 client. Okay, so you can see, let me actually just tell you what the important thing. Where's the result? Okay, you see that this is the distance. This is the distance that you're getting, right, for the compute. So right now, I'm actually running the program just like, okay, don't worry about this part. This part is something to do with web reporting, because I haven't turned on the web reporting from the server, but the program can run. Even the web reporting is not. By the way, this program right now running on my same machine. I've just created 3 different windows, but it actually tried to report some of the things to the web server to tell the server that what the interaction is. I will talk about that on Monday. But when I'm executing this program, you can see the server actually received something. You can see that the server received exactly the same VSID, and then it realized it's a fly JSON string. And then they basically call the get distance, but somehow one of the object is on another machine. So that's why another machine will also get some of this. You see that this is getting a little bit. HW3 another is getting a little bit for that. It's actually getting the VSID and then try to provide that particular string. So essentially what I have, if you only look at the client, is really very similar to what your homework assignment number 2, part 2 is. It's just try to get the distance between the object. The only thing is that it actually call HW3 server first. And then HW3 server will actually grab some other information from HW3 another. And then through this interaction, they coordinatively, they actually complete this, okay? And this sounds complicated, but if you see the package we're using, we're actually leveraging the JSON RPC package. In fact, to do this is quite mechanical, means that you allow the JSON RPC to generate the code for you for the communication. And then you just, based on the code they generate, you hook things into that. So in other words, the code generated by JSON RPC is like a reference implementation, just like your homework assignment number 2 with a lot of holes. So people ask me, why I ask students to do this kind of reference implementation? Because in real world, that's what happened if you use some kind of template like a JSON RPC. It's not going to let you write all the code. It's automatically generate, and you can copy to both client and server side. You just add a few lines, and then the code will run beautifully together. Okay, all right. I'm going to stop here and switch to the other room. Let me stop recording first. Before I stop, question. Yeah, go ahead.
So for homework 3, we can reuse the objects of flight and person and GPS and all of those, right? All those classes?
Yes.
Okay.
Yes.
Thank you.
Yes, I mentioned there are 2 things you need to run. Number 1, you need to support get distance. The other one is conflict of interest. Those 2 functions, okay? You implement those 2 functions across that. The semantic of what conflict of interest is and what get distance is actually defined in
already in the classes.
2. Yeah.
Yes. I think there is another third method or function. It's same person. I think it's on the
right. Same person is overloading operator equal.
Oh,
right.
Okay. I mean, I thought it had to be like another request from the client. Like
yes, you have to have that. That is also a function you will call remotely. Yes, I'm sorry, I forgot to mention that. It's operator equal. So when you think about operator equal, you will think that, wait a minute, operator equal has to be running on the same machine. No, this is actually show you even the operator equal itself
can be run.
Distributed over.
So then, machine. Because the way I think the way it works is that you create a shadow object which has a virtual function, which is the one that the derived object or derived class overrides, and then in that, when you declare the new function, the new virtual function, then that's when you make the request to the server. When you create myv.
So let me explain what the shadow object is. So shadow object is that assuming this object, let's assume this object is a flight. Assuming this flight, the real copy of the flight object is in New York. So for me to access to that object, I actually create a shadow of that object in Davis. So when I'm working on the program, as if I'm actually accessing a local object, which is called shadow flight in Davis, but inside that shadow object, it has information to forward everything I invoke, the local one to the remote one. And then the result come back. So you can think about the shadow flight is really a wrapper that I'm interacting with. So that's the concept.
Is that why you pass, the arguments like host ID and class ID and object ID and all of that?
Right. That's right.
So in case we wanted to, like if
no,
we were to define...
we only have those in the constructor, by the way.
Yes.
Shadow object only, because at the time you create the shadow, you should let the shadow know which object they're corresponding to. That's why you have the URL and things like that.
Yes. But so again, you were saying that we need also to get call the overloaded operator the double equals to operator.
Yes, we can.
Right.
The shadow also support that.
Oh,
The
okay.
shadow
Okay.
also support that.
It cannot be just like a normal function. It has to be an overloaded operator.
It's actually overloaded in shadow as well. But then when you
Mhm.
overload it in shadow, it will actually send it to remote as well.
Yes. Oh,
Let me do that more. I think other students are kind of may need to see the whole thing more systematically. So Monday, let's go over this again. Okay, a slower pace with a lot of example, with code segment, and I want to make sure that everybody understand the concept. So you will be able to take care of this assignment. Okay.
Okay. Okay.
Yeah.
Thank
I
you,
mean,
Professor.
this is not an easy assignment, and just be honest with ecs36b, it's not an easy course, but
Yeah.
we work
Yeah.
together.
It seems like
okay.
it. I
Yeah,
think
we
I
work
already got it.
together.
But thank you for your support.
Yeah. So for those of you who are not in group number 3, you have a good weekend. I will see you on Monday. And if you have some any question for homework 1 submission, let me know. Okay, I'll usually the last night I will check my email more often. But this week, again, I have some other outside activity from Washington, D.C. I was really horrible. So for the group 3, I'm going to move into that right now. Okay, thank you.
How do we know what group we're in?
You should receive an email. If you haven't received an email, let me know.
To our UC Davis email?
Yes, UC Davis email. Yeah,
Okay.
I send a link. But if you miss one, I can just reassign you to a different group. Right now, I think the group are pretty small, so it's okay to add another student. Okay.
Should we join the meeting in the link that you sent in the email?
Yes.
Okay.
The link I sent to group 3. I
Okay.
actually create 6 groups. I want to have a separation to make sure that I got really smaller group. Okay.
Okay.
All right. Thank you. I'm going to stop recording.
Well,
Sorry.
Professor,
Yes.
I need to make sure to get some help tonight specifically because I can't get my break to run.
Okay. Mia, do you think it's okay if you have a time, we can have a Zoom, or anybody have a time. Let's do it this way. Tonight around maybe 8:30. Let's come back here. Would that be okay? Come back to this link.
To this link? Okay.
To this link, yeah. 8:30. I will be back.
Okay, thank you.
Yeah, I mean, email is just impossible for me. I receive way too many email. I prefer to use Zoom to talk about. If you have any question for homework 1, and come back here 8:30. Okay, I'll be here.
Okay, thank you.
Professor, I can or like anyone can join that, right?
Yes, anyone can join.
Okay.
Yeah,
Awesome.
anybody can join. I will make an announcement. Okay. Thank you. Bye.